Okay, this is lesson 5.3, difference of perfect squares, our first lesson in the quadratics unit. This is a lesson on one strategy of factoring. Because the strategy is called the difference of perfect squares, it's important to know what a perfect square is. That's what page 1 is about. If you click through these, it'll kind of give you a couple of examples, but overall, a perfect square is an integer value that is multiplied by itself. So for example, 36 can be multiplied as 6 times 6, it is a perfect square. In class, you probably learned a calculator trick to test a number, and that is to use the squaring's opposite of a square root. So I can test a number by trying to square root it. So if I hit second in this x squared button, I get the square root symbol, and then I put the number in it that I'm trying to test. So if I try 36, I get 6. So 36 is a perfect square. To show you what it would look like if it does not pass the test, we'll do 33. You would get a big messy decimal. So that means 33 is not a perfect square and 36 is. Page 2 is all about the strategies for how to tell and then actually how to go about factoring. It seemed a little confusing on this page, so I actually put the examples here. Now here's the test to do. So the first thing you want to look and see, are there two terms? If there are 3 or more terms, you can't use this difference of perfect square strategies. Then you check and see, is there a subtraction symbol in between the two terms? If there is, keep going. If there isn't, you can't do it. And then the third step is you look and see, is everything, numbers and letters, perfect squares? Okay, so let's try this first example and we'll do the test. So the first thing you want to do, is there 2 terms? Yes, there is. 1, 2. Is there subtraction in between? Yes, there is. Are they perfect squares? So you could, either by memory or by the calculator, you could test each one of these. So if I do, all right, so I know that 3 times 3 is 9, and I think 16, oh, I remember, 4 times 4 is 16. These are both perfect squares. So, and then in terms of the variable, so variables with even exponents are always perfect. And there's actually a spot in the on page 2 where they kind of talk about that. So if you need more information, you can kind of get that. So in order to, and then they talk about the format. When we have the difference of 2 perfect squares, we will always factor out with 1 positive and 1 negative. And then in order to get up the pieces, what we do is we take the square root of everything, again, undoing it. So we would take the square root of 9, which I already got on the calculator. So that means that the square root of 9 is 3 times 3. The square root of x squared, what happens is this square and these cancel out. So the square root of x squared is x. Okay. So that means it would be x times x. And then lastly, we do the square root of 16, which again we talked about earlier in the video, is 4. So that would be 4 and 4. And that is how you factor the difference of 2 perfect squares. If you were to check this and you were to do the box method or the double distributive and you were to multiply this out, it would equal this, and that's how you check it. For the purposes of the quiz, you won't have to do any checks, but that's just for memory. Okay, so that's example 1. This is example 2. So again, we do the checks. Are there 2 terms? 1, 2. Yep. Is there a subtraction symbol? Yep. Are they perfect squares? Well, we already know that 9 is from here. X squared, it doesn't matter if it's x squared or y squared. If it's an even exponent, it is perfect. Okay? So we know that the x squared, and then 4, earlier in the video, I already mentioned that was an example. We know that's 2 times 2. So we can kind of get our 2 factors ready. We know one is going to be plus and one is going to be minus. And then we go ahead. The square root of 4 is 2. You see how I kind of take it piece by piece? The square root of x squared is x. And now you don't necessarily have to write all this out. This is what I'm doing to kind of show you the pieces. If you can do this in your head, that is absolutely fine. I already know this one. The square root of y squared is y. And that is the answer. Okay, last example. 2 terms? Yes. 1, 2. Is it subtraction? No. If you get in a situation where we can't use it, okay, this cannot be factored. For the purposes of the e-learning, what they're going to do on the multiple choice is this will be one of the choices, and that's what you want to choose, prime, okay? So if you get to a situation where they say factor this using difference of perfect squares, if you can't factor it, one of the choices will be prime, and that's going to be the correct answer. So I hope that helps. So going back into the study guide, there's another one right here for you to check. And actually, I think it's a video for you to watch. Yeah, so if you wanted to kind of see it, and then there's more examples here where you could try and practice more on your own. And you want to kind of keep doing enough till you feel comfortable. Sometimes you'll be able to do the difference of perfect squares, but not right away. If you guys remember from last year, GCF, sometimes that's what happens. So, for example, this one right here, okay? If you were to do the test right away, x squared is perfect. I've got the minus, but neither of these are perfect. However, with a little bit of extra work, this one has a GCF. It has a 3 that can be divided out of both of them. So if you remember the GCF rules, you take the biggest number or letter that you can divide out. That number ends up on the outside, and then we cancel stuff out. So these 3 divides out. I'm left with the x squared, and then I have a negative 27 divided by 3, which is negative 9. So now, with an extra step, this right here, I can test this now. So let's look. 2 pieces, subtraction. I know x squared is perfect. I know 9 is perfect for my earlier problems. So this in here, I can factor. The 3 has to follow, and now we're going to split it up into its 2 factors. So do the square root of x squared and the square root of 9. Remember, one's plus and one's minus. And this would be the full answer. So be careful, because some of the questions on the quiz will look like this. Don't pick prime, because this is kind of like a 2-stepper, where first you have to check for a GCF, and then you can factor. And I know there's at least one question like that. So you want to be careful and pay attention to the type of problem that you're doing. There are a couple of problems you can try to make sure that you're comfortable doing this. I would highly recommend it so you can start seeing the difference between when there's a GCF and when there isn't, and when you just can't factor at all. Okay, moving on. I would actually skip the next couple of pages. Those are the main things you need to know. You need to be able to tell when you can't use it, when it's prime, how to factor one that is all set to go, and how to factor one where you need to do a GCF. So I would actually recommend just skipping ahead to, actually, you can do 5. Just do sample problems, okay? So you want to try these sample problems on 5, and try these sample problems on 6. And if you can do those, you're ready for the quiz. If you have additional questions, ask your teacher, and good luck on the quiz, guys.